And welcome to this video, which is the first in the year 2026. So before we get into, I would like to wish you all a very happy new year and a great 2026. May all the wishes and stuff that you want to do, have planned for, comes true. With that said, let's get into the details of our course, which we have started last year on quantum gated logic. And up until now, we have covered what you called as the basics of quantum circuit in terms of the qubits, how it is arranged, uh, and what happens when the operations are being conducted on that. Now, a circuit is not complete unless or until we do operations over it. And by means of doing the operation, we are talking about gates. In this case, quantum gates. So what does quantum gates do? In a nutshell, as already said, they perform operations on the qubit. Technically, or in the mathematical sense, their main purpose is to alter the amplitude of a qubit. Now, I hope you recall from the previous videos on the basics of qubits that it carries an magnitude, it carries an amplitude, uh, uh, a square of which, when you add together, will give you a result of 1. So the purpose of quantum gates is to alter that amplitude in terms of giving it different values and then conducting the operation. Now, if you look further deep down, quantum gates are nothing more than matrices. And what are matrices? For that, I suggest you to look at the series on quantum linear algebra, which we have also did last year. And in terms of what they are a group of um, mathematical numbers, be it in a square or a rectangular format. And what they do is they help you to multiply, change things in a much more structured manner. But for more on that, you can obviously watch the series on quantum linear algebra. So the quantum gates are matrices, and qubits, as we have also seen before, are vectors. Now, if you multiply a matrix to a vector, you get what you called as an altered vector. That is what we are talking about in terms of altering the amplitude, and in terms of vectors, beside amplitude, we can also alter the phase or the direction of the vector. That's why we get an altered vector. Now, some important properties of quantum gates, very important to keep into consideration, is that they are unitary matrices. So if you do not know what is an unitary matrices, do look at the course on quantum linear algebra. And the purpose of unitary matrices, if you draw a parallel to a number system, then that unitary matrices represent what number 1 represent in the numeric system. And the purpose of the unitary matrices is that they keep the sum of probabilities to 1. So as we said, that if you square the amplitude of a qubit, sum total should add up to 1. So all the probabilities should add up to 1. How does a unitary matrices is represented? It's represented by a symbol I, and when will you call in matrices and unitary matrices? It is when the matrix and the complex conjugate of the matrix multiplied result in a square matrix of 1 at the diagonal, be it of any dimension, but 1 at the diagonal, and that is when it's called as an unitary matrices. I, in terms of their, in terms of that definition, represents what is called as identity. So it is important that you be clear about the definition of what an unitary matrices is, because that will really help you to digest this information. Now, another important property what the quantum gate does is that it helps us to do reversible computing, which means you can go back from an output to an input sequence. Now, if you draw a parallel, for example, with the classical computing, barring a single gate operation, gated operations like NOT, it will be very difficult to go back from output to input. How so? If you look at the classical AND operator, it is a 2-input gate and it gives a single output. So for example, output 1 comes when the input are 1, 1, and output 0 when either one of the input is 0 or both the inputs are 0. However, the tricky bit is, if the output is 0, how will you determine from which input 0, 0, 0, 1, 1, 0 that it came from? And that is where quantum gates plays very important role, because unlike classical gates where the number of inputs and output may differ, in case here in the AND operator we say for 2 input we get 1 output, in quantum gates it is input to output match. For example, if there are 2 input states presenting information, then the output state will also be represented in two outputs, which is then help you to kind of get this reversibility aspect. So with that said, I'll stop here, and in the next video we're gonna go deeper into building an actual quantum circuit, or at least to see how this is being built, and from there we will go further on different aspects. Thank you very much for listening, and a Happy New Year once again.